All right. Hello, everyone, and welcome to the stream. Hope everyone is doing well tonight. We are back with the next episode of the Kohi Game Engine series / Shadows of Illumina. We're going to talk a little bit about that in terms of some of the changes that are coming up with that here in just a minute. But before we did jump into that, I did want to just take a quick second and thank the supporters of the channel, beginning with our highest tier of support over on YouTube memberships and Patreon, the elite partner Javier Alazaran, followed by the next tier there, Gerbilies Inc. and Matt Osgard. They are partners. Followed by the list of supporters you see listed here on the screen. They are a combination, rather, of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. I greatly appreciate it, and it helps me cover the costs associated with running this channel and project. Things like software licenses, hosting fees, eventually assets, hardware costs as they come up, things of that nature. So thank you very much to all of you for that support. It is greatly appreciated. And of course, I appreciate you guys, the viewers, each and every one of you, whether you're joining us live here on the YouTube side or the Twitch side. I do appreciate you guys very much. Or if you're catching the VOD after the fact, I appreciate you guys being here as well, because without you guys, the viewers, this project and this channel would not exist. So thank you guys for being here. It's very much appreciated. Okay, let's see. I am not even going to try and pronounce your name over there on the YouTube side because it's in Cyrillic and I can't read it, frankly. But it says, welcome back. It's been a while since you've been doing development. I would like to hear some advice about game dev. I want to build 3D game using Vulkan and custom allocator. Well, good luck on that, first off. So good news on that is we've done those things here on stream. So we've built a custom allocator, although it still needs work and attention. There is an example of using a custom allocator with Vulkan. And how you might set that up. So I know there's a video in the series on YouTube. I forget exactly what episode number it is, but it is something that is available there as far as an explanation as to how it works. And then, of course, the repo is available as well. So let me see if the bot is going to work tonight. I swear, Streamlabs bot is getting like worse and worse about like accepting and responding to commands. Okay, let me put in what that's supposed to do. That is supposed to be dropping a link to the Kohi engine website. Let's see, did that not? Give me a second here. There we go. So there's a link to this website, and from this website you can find the link to GitHub, which will take you here. And within this, you will be able to go into the Vulkan renderer plugin. GitHub is really slow today, apparently. Wow. Really, GitHub? I know it's not my internet. Jeez, that took forever. Okay. And then in source, there is in the Vulkan backend .c. I think it's all the way at the bottom. You can actually find Vulkan create allocator. If you take a look at essentially the vtable that it sets up, and then all of the examples there of the allocator, essentially this points to our dynamic allocator by using kallocate. But all of this stuff is all available on YouTube on the series we've done. So yeah, GitHub moment, exactly. Yeah. That was pretty terrible in terms of performance. I don't know what's going on there. What is a nav map? Did I type nav map or did I type, I meant nav mesh. Did I type the wrong thing? No, I typed nav mesh. So we'll get into what a nav mesh is here in a minute. But before we do that, I do want to just, kind of go over a couple of housekeeping items first. Oh, wow. A raid already. Okay. That was quick. Welcome, raiders. Thank you so much for the raid. The Code Drift is raiding with a party of 29. Well, welcome, raiders. Uh, Very good to see you. We're actually just getting started on stream here. So, welcome, everybody. Apotham, good to see you. Yeah, welcome, raiders. Okay, so I guess what I'll do here before I actually get into the things I wanted to talk about is I will give a quick spiel as to what we're doing on this channel. Really quickly before I do that, though, the Code Drift, what did you get up to on your stream? What were you up to? How did your stream go? Hope it went well. Whoa! Thank you, Anonymous, for the 5 gifted subs. I really appreciate that support. Thank you so much. That means a lot to me. I really, really appreciate that. Thank you very much. We were waiting through the intro. Fair enough. Okay. All right. So I'll give a quick, as quick as possible, introduction as to what we're doing here. So on this channel, we are building a game engine from scratch using C and Vulkan as our initial rendering backend. I say initial rendering backend because I do have plans to support Direct3D and Metal as well. So we've architected the engine in such a way where it will support multiple rendering backends depending on platform, the target platform. So the idea is that we're building a game engine from scratch, and then we are building a game on top of that game engine that we're going to take all the way to release and release that game on Steam. And we're sort of bouncing back and forth between engine development and game development at the moment. We've done a lot of the legwork as far as the game engine is concerned, and so now we're kind of adding features to the engine as we need them, and then switching back to game development on the game side and so forth. So it's kind of a delicate balance of bouncing back and forth between those two things. So the entire thing has been done essentially on video, and parts that I've done offline have been covered on video. And so essentially my goal with this was to kind of create and document the process of creating a game engine from scratch. And so that means in the core runtime, there are no sort of libraries, with the exception of the ones we have to use, like the OS and Vulkan and things like that, with a couple of small exceptions, and I can get into those in a minute. But we are stepping through the process of building a game engine, and this is a way of building a game engine completely from scratch using C. So it's a way of building a game engine, and I stress that because it's not the only way to build a game engine, and it's not necessarily always the right way to build a game engine. I'm doing this as a sort of educational resource, and so there's lots of trial and error and experimentation that goes on the channel. So this started off as a sort of a tutorial series. We outgrew that format. I've been trying a variety of different formats on the channel, and we kind of landed on live streaming at the moment. And we're actually getting ready to start some new format stuff here in a bit, and some changes to the channel. Just trying some other things. Anyways, a little bit more about the engine. It is free and open source. So all of that code is available on GitHub. If GitHub likes to load, sometimes it doesn't, as we just had here a minute ago. The engine itself is Apache 2.0 license, which basically means if you want to use it, whether it be for a personal project or commercial, it does not matter. All that I ask is that if you use it, you just say you used it. And so the main website here, I'll just drop this on chat there for you guys. So the main website here sort of acts as a portal to all the various resources having to do with the engine and a little bit of information therein. And so I'll just drop that there, and you can find the GitHub link from there. A couple more things is this isn't a royalty-free engine, so the engine will always be open source. It's never going to be paywalled. This is an educational resource. I believe that stuff should be free to learn, and so I'm never going to paywall or have any sort of licensing or royalty fees of any kind ever having to do with the engine. The game we're developing with it is going to be closed source until after that game's released, but it is going to be built on top of this open source engine. The engine itself is cross-platform, so it runs on Windows, Linux, and Mac OS at the moment, with other platforms planned in the future. couple more things on the website here. You'll find some links to the YouTube and, of course, the Twitch channel. I do have a forum where I've just recently launched this, where we can kind of discuss things. I'm trying to move away from Discord because Discord's a bit of a sort of a walled garden, and they've pulled some stunts recently that I'm not really huge on. So we do have a Discord server. It's got about 1,000 people on it. But I am trying to point people more towards using the forums, especially for discussion having to do with the engine itself. Other than that, there is a GitHub link here, and then if you're interested, there's a Patreon link there. And I believe that has pretty much covered the introduction as far as the engine is concerned. As far as the game that we're making on top of that, the game is actually called Shadows of Aluminina. It is a 3D action RPG with a isometric perspective. And so that is the main game that we're kind of building on top of that. We're very early days in that. I think at the moment I can actually run it, if I haven't actually broken anything. So it's very, very early days here. But we have the ability to sort of roam around in this 3D test scene that we've got here. I've been working on Navmeshes, which was actually what we're going to talk about tonight. And so there's that. Also, there is a editor that is built in that allows us to edit all sorts of various things having to do with the world, including different entities. So we can select those things and move them around in the scene, or we can go into the terrain editor and change textures on the materials, or we can actually paint different materials on there, and so forth. You can see that happening right there. We can change elevation. We've got a bunch of different tools that we've been kind of working on building along the way. And so we built all of this completely from scratch. And so obviously that's a large undertaking. The project's been underway for about 5 calendar years now. But the large caveat that I want to make there is that it has been less than part-time hours per week that I work on this. So it's usually a maximum of about 10 hours a week that I can put into it. So if we were to condense that down to full-time hours, it's really just about a year's worth of work full-time. So, okay. That is sort of the introduction there. Cable Monkey, thank you for the tier 1 sub. I really appreciate that. Thank you very much. I appreciate that support. Let me just catch up on chat here, see if I missed anything. Sounds interesting. I appreciate that. Let's see. Stream went incredibly well. We spent a lot of time working on zero trust design for the startup. Awesome. Okay. Let's see. I am going to toss you a follow. Thank you again very much for the raid. I really appreciate that. Only a year worth of work. Yeah, I mean, roughly. Full time, right? Yeah. I guess at this point, it's technically a little bit more than that. I guess it's like a year and a couple months. I think YouTube deleted my comment on your last YouTube video, but I finally ordered a vertical mouse and a split keyboard. Should be here tomorrow. That is awesome. Your hands and your wrist will thank you for that. That's good news, Apotham. Let me see. From says, hi, support is given. I'm off to bed. Good luck. All right, From thank you for being here. Appreciate you. Seeing you over on YouTube. Good to see you as well. Okay, I think I'm caught up. Perfect. All right. Looking good, by the way. I appreciate that. Thank you. Split keyboard is a real game changer for comfort. Yes. And actually, we've had lots of conversations here. I missed about a month worth of streaming because I had to have carpal tunnel surgery, which is why Apotham is mentioning that, because I've been doing a lot of talking lately about ergonomics and things like split keyboards, vertical mice, trackballs, things like that, taking care of your hands, right? So you hopefully don't run into the same issue that I had and have to get your wrist operated on. So, yeah, that's a thing. Okay. So, I think I can exit this now. didn't really want to promo, just been in developer tools for a decade plus and saw a need that wasn't addressed out there. So fixing it, that's awesome. Those are the best kind of projects, right? 100%. Thankful some other folks saw it too and felt it was worth investing in. Now comes the forever building phase. Yeah, the tough part, right? For sure. Fingy's number one. Yeah. Yeah, so addressing an actual need that's out there is huge, right? Like Ryan Fleury is doing with Rad Debugger. Because eventually, I'm hoping that on Linux I'll be able to get rid of this piece of poop in terms of having to debug with this guy, right? Anyway, I digress. So, what are we going to talk about tonight? Well, there's a few things I want to talk about in terms of just house cleaning items, and then we'll get into what the actual main discussion is going to be. So, up until now, we've been doing Wednesday and Thursday night streams. And I announced on the last stream that I'm going to be pulling back to one stream night a week, just so that I've got a little bit of time off camera. I just noticed my camera is kind of a foobar angle there. You fix that. So that I've got a little bit more time to actually get some coding done, right? Because it's kind of difficult to do that and stream at the same time. So I don't want to stop streaming. I like interacting with you guys and having the chats and doing the explanations and all that stuff. But I found that, it's really difficult to kind of keep the project moving forward sometimes. So I'm going to be stepping that back to one night a week, as I announced before. And so before we were doing Wednesday and Thursday night streams, last week, I did a Wednesday night stream, and this week I'm trying a Thursday night stream. So I haven't decided which night I'm going to go with yet in terms of Wednesday or Thursday night. I'm kind of leaning more towards Thursday, to be completely honest. But it may switch back and forth for a little bit until I kind of figure that out. So I just want to bring that up. And then, let's see, just here to sharpen my C. Thanks for being welcoming to us all. Of course, yeah. I appreciate you guys being here. And this whole project's written in C. So if you want an example of how to do that, here you go. And the project is probably, I think it's pushing 100,000 lines at this point. So it's not a small project. Let's see. Okay, so episode numbering and YouTube playlist. So at the moment, if we go to my channel, so if we go here, and let's see, collapse that so we can see what we're looking at here, and we go into this, I've got a few different playlists here. So I've got game dev from scratch, Shadows of Aluminina, 3D action RPG using my custom game engine. And so this is basically where I started doing the game code, right? Separate from the engine, and started actually developing the game. And so this is one playlist. And then I have this Vulkan game engine series written in C, and this is the main playlist for the engine. The problem is this playlist also includes some stuff about the engine. So what I'm going to do is, instead of having separate playlists, I'm going to combine all of these into the Vulkan game engine series written in C. Might rename this playlist to, maybe just the Kohi game engine series, and combine the Shadows of Illumina into that. So I'm going to renumber all of the episodes so that they line up with that. I think this playlist here, I think stops at like episode like 320 or something like that. And then we've got upwards of 60 episodes between the sort of thing that we were trying in between this project and the last. And so, we're going to be bumping up those numbers a little bit, but it should make everything a little bit easier to navigate in terms of like what playlist you should start with and whatnot. So I'm going to be renaming a lot of videos in here and changing the episode numbers. And so the next time the stream comes up, I should have all that done. And we're on episode 54 now, but that number will likely be, I think, 400 and something by the time we're done. So just so that you guys are aware of that change coming. And the other thing I wanted to talk about is I did pick up a copy, because I always am talking about this book a lot, because I've referenced it a lot through this whole series, the Game Engine Architecture book, right? And I've gone ahead and picked up the newly released 4th edition. So the 4th edition is actually 2 volumes, right? So essentially all the stuff that was added to this from or over the 3rd edition basically made the book too big, so he decided to split it in 2. And so I'm currently making my way through that book now. I've read the 3rd edition cover to cover multiple times. It's an excellent book. I intend on reading this cover to cover, both volumes, and then I will provide feedback and or a review on that once I've made it all the way through the book. So I just want to let you guys know I am working through that. I do have the 4th edition, and so once I make my way through that, I'll be able to provide feedback to you guys on that. JSpeak just got the 3rd edition, so there's not a ton of stuff, as far as I'm aware, added to this over the 3rd edition. I'll have to look for a list of all the specifics, but if you have the 3rd edition, that's certainly fine to start off with. Are there supposed to be significant differences between the 3rd and 4th? He did list all of that stuff off. I can't remember what it all was between, or off the top of my head. But there were several sections that were added, and a bunch of errata that were fixed, and I don't, like I said, I haven't made it all the way through the book yet, so I don't recall. I thought he listed that in here somewhere. Maybe not. Let's see. I don't think it's like in bullet point format, so I'll bullet point format it out once I get through it. And the reason I bring this up is because I recommended the 3rd edition a lot. And so I want to go through the 4th edition and see if it's worth grabbing, right? So I went ahead and grabbed it, and I will go through it and let you guys know if it is a significant enough difference between the 3rd edition and the 4th edition that you should run out and get it or not. Regretting not getting the 4th. Yeah, I mean, it just came out, though. Like, I've only had that book for maybe a couple weeks. So, there's that. I picked up the 4th edition as well, but haven't had the time to really get into it. Yeah, that's been my kind of issue as well. I haven't had a whole lot of time to get into it just yet. Which sections do you reference the most? I would say probably some of the higher level stuff, some of the stuff around allocators, some of the various systems that are outlined in it, some of the architectural decisions that are made. We've actually diverged from that quite a lot in terms of, we don't follow it exactly on this channel, not even close actually. But I do take a lot of those concepts and sort of run with them. So it's not something I could probably list off really easily. But I've taken lots of cues from the books over the years, for sure. Cool. All right. Regardless, even if you're not sticking to it, if you're looking to get into game engine dev, it's a really good resource on getting started with that, and wrapping your head around everything that goes into making an engine. All right. So that's the game architecture book, game engine architecture book. And now we're going to talk about Navmeshes. All right, so I've done a little bit of work already around Navmeshes. And you can see here in the, as long as my head's not blocking it, this section here, we've got a few to-do items around Navmeshes. So I want to talk a little bit about what a Navmesh is and what it can be used for, and then talk about some implementation details, and I guess we should probably start this off with a visual example. So the way that I've implemented this, and I do have a kind of an implementation of this, but I implemented this in game code. And so for those of you who are new to the channel, essentially we have everything that's listed as Kohi here as part of the engine. And then Illumina here, everything that's under that, which is mostly under here, is all listed as, where is it? So avatar system, player avatar, all of these things are game code. And the reason that I did that was because it's very easy to sort of play around with things in the game code. And then once we have an idea kind of solidified, we can then move that into the engine and make it fit for being consumed by game code instead of actually existing in game code. So I did most of this in player avatar because our player avatar is what we are actually controlling at the moment and running around the screen. And so that was, just kind of made it convenient to kind of put it all in one place so I can kind of start debugging that. And so I think what I'm going to do is I'm actually going to shut up some of the logging that I've got in here. I think it was that one. Oops, I don't have... Let me actually do this. So let me actually do this and then kill that one. All right, we don't need those notes anymore. Okay, so essentially what we have is all of the sort of Navmesh stuff is in here. And this code's kind of messy at the moment because I've been playing around with a lot of different things, and it's not perfect yet, but it's good enough to at least kind of show off how this whole thing is going to work. So we're going to get into what this code is and how it works in just a second. But for right now, all of that stuff lives in player avatar. So let me go ahead and launch the game. So, oh, I thought I got rid of that. Did I not build? Hold on. Did I get rid of all of the... I'm trying to get rid of the log noise, essentially. Let's see. Oh, edge. Where we are creating the edges. Did I get rid of that? I think it was a K-trace. I must have. Okay. All right, so let's build this and try rerunning again. All right, there we go. That's good enough for now. All right. So the nav mesh is essentially, right now it's being rendered as a normal mesh, right? So what a nav mesh is essentially something that we can use. It's a piece of freeform geometry that we can use for navigation, hence nav mesh. And the idea behind it, and you'll notice that the console's sort of going crazy here because I'm printing a whole bunch of stuff. And that's incidentally why this is going up like crazy. So essentially what this is it is a mesh that we can move along. So you'll notice as I sort of move the player along here, he kind of follows the shape, the elevation and whatnot of this particular mesh. And if I approach the edge, I just kind of slide along the boundary and things like that. And so what we can use is essentially the data within this to say, well, this is kind of the walking area that I'm restricted to, and I should not be able to walk outside of this. And essentially the idea is that we're going to use a collection of these to navigate around our world, right? Because there's only going to be certain parts of our world that are going to be fit for navigation. And eventually these will be auto-generated, but for now, I've gone ahead and just used a mesh that I've already created in Blender, which is here, right? So this is a very simple mesh. It looks like that, right? There's not a whole lot to it. It's really just, something simple that I can sort of test with. And so I exported that and then imported it as a mesh asset, and that allowed me to drop it here in the scene. And then I can use that to move my player along. The other thing is you can use this essentially to say, let's say, for example, we have a player that's standing on this particular triangle, right? And we have an enemy that's standing on this triangle. And so we can actually use this adjacency data, and we'll go into that here in a second, to say, well, which path should I take within this mesh to get from here over to here if I'm the enemy and I'm trying to attack the player. And so that's another thing that's probably the primary use of Navmeshes, right? So it's moving along them, but it's also using them to get from point A to point B. So that is essentially what they are going to be used for. And you'll see here, if I actually go into the editor, right now I've got it imported as an actual mesh. And essentially the way that this works is I've got a spawn point, which is this entity here. And so this spawn point exists relatively close to the surface of the nav mesh. And then I essentially spawn the player and snap them to the nav mesh and say, this is the nav mesh that we currently want to be using. And then the player is free to navigate that. The idea is that we'll have multiple nav meshes. So we may have something where perhaps there is a nav mesh that looks like this, and then maybe there's a duplicate of it, or another nav mesh that is maybe next to it but spaced away for a little bit, and maybe further up, and they're connected by a ladder or something like that. And so we'd have some sort of sequence where we enter some sort of trigger at the bottom and allow the player to climb up the ladder. And then once we get to the top of the ladder and we unmount from the ladder, then we essentially bind the player to that nav mesh, and they can move around in that particular one. And so that's a very simple way to give us movement without having to have an entire physics system, which we really don't need. And it'll also allow us, of course, to utilize that when it comes to building enemy AI. And so that's kind of the idea there behind that. Let's see. I thought they use invisible walls for that. So invisible walls are something you can use if you've got an implementation of a full physics system, which we don't. The reason for that is an action RPG really doesn't need that, right? If you think about the way that most action RPGs work, they're either heavily grid-based, or they've got some sort of navigation like this, where you can sort of free-form walk within a certain area, and under the hood, this is what's happening. So I thought about going grid-based, but I decided against that, at least preliminarily, just because it felt kind of restrictive. So I'm trying out the nav mesh to see how this works. If we hate the idea of the nav mesh and really don't like the way that works, maybe we can go with some sort of grid-based movement system. But I figured this allowed the player a little bit more freedom of movement than, say, something like Path of Exile that's very grid-based, and you have to click, and you're only able to move within, certain vertices within that grid, right? Which there's nothing wrong with that, right? It just wasn't the system that I necessarily wanted. So it's all different systems, right? So like I said, we're trying this, and we're going to essentially implement movement and then combat on top of this and see how that feels. And if it doesn't feel right, we'll try something else. There's a good Handmade Hero video related to that. Yes. What was it called? It was like Killing the Walk Monster or something like that. But the system they built was like way beyond the scope of what I'm going to need. But yes, it is a great video. Want to get into engine dev as a hobby project? What should I aim for as baby's first game engine? Very interesting stream, by the way. Thank you for that, and welcome, by the way. So, yeah, I did get it right, Vincent. Okay. So, in answer to your question, in terms of baby's first game engine, I usually suggest that people start with 2D, believe it or not. I know we're doing 3D here, and that's because there's lots of people that do 2D, right? But there's a reason for that. It's much easier to sort of wrap your head around the concepts. I usually say folks should start with, I would say, start with whatever language you're comfortable with, first off. If you want to learn a different language or you want to pick up C, do that separately from learning a game engine. Don't try to learn C and Vulkan and game engine design at the same time, right? Pick one thing and stick with it. So use whatever language you're comfortable with, first off. And then in terms of writing like your renderer and whatnot, that'll somewhat be dependent on what platform you choose, right? If you're going with a browser, you're probably going to use WebGL or WebGPU, versus if you're doing local development like this, you'll probably want to start with maybe OpenGL. Although I'm kind of leaning more towards these days telling people to start with DirectX, right? Like DirectX 9, because they're a lot simpler. Those two APIs are a lot simpler than Vulkan, right? You don't want to start off with Vulkan as your first renderer. Use OpenGL or DirectX to write your first couple of renderers to wrap your head around the concepts. And then don't just focus on the renderer, focus on the game engine as a whole. All the systems that you're going to need, figure out how to write an editor, figure out how to write a tile map if you're making like an RPG or something like that. Figure out how to write basic collision for that, 2D collision, but start 2D, keep it simple. And don't overcomplicate things. Don't look to abstract everything right away, because that tends to lead you into corners where you have to do heavy refactoring. Even with something like this, we fall into that trap a couple of times. So, and I've been doing this quite a while, and I still fall into it every once in a while. So, you heard Vulkan is pretty gnarly. Yeah, it's just, they've got lots of stuff in there for legacy hardware support, which is really annoying. And some of the newer versions of Vulkan simplify a lot of that stuff away, but it's not necessarily always supported widely on hardware, which is why it's super annoying. I get what they were trying to do with Vulkan. I don't think it's really worked, right? And truth be told, had I used something like DirectX or OpenGL instead of Vulkan, I probably would be a lot farther along now, because it does take a lot to work around some of the issues. That being said, it is the way that APIs are going, right? So DirectX 12, Metal, I think is probably, at least from what I've heard, is the most sane of the three. And we're going to be learning and implementing that on stream at some point as our second backend. But for right now, it's just Vulkan. But if you're really wanting to learn graphics programming, you're going to need to use one of those APIs. So you're going to need to learn it at some point. I just don't suggest it for you first. Dark Score, first time chatter, welcome. So I hope that helps. And also reading game engine architecture front to back is a big deal, right? So like I said, this is the 4th edition. If you don't want to pick that up, the 3rd edition is perfectly fine. I've been recommending this for years. It's a thick boy, right? It's 2 C's thick at least. But I did pick up the newly released 4th edition, so I haven't finished reviewing that yet. Hopefully soon. Pretty much nowadays, just ignore the stuff in Vulkan for legacy. If the card doesn't support Vulkan 1.3, just fall back to OpenGL. That's actually, I think, what I'm going to wind up doing in this, believe it or not. I'm going to probably wind up removing a lot of the legacy stuff out of our renderer at some point, and just falling back on GL. So when I started this, when I started writing this, I think the newest version of Vulkan was either 1.1 or 1.2. I think it was 1.1. So a lot of that stuff wasn't available, but anyway, Just so sick of InfoSec lately, I want to pick something else. Yeah, fair enough. It's always a good thing to learn more. Never a bad move. We catch up on the YouTube side real quick. How's everything going? Going pretty well. Thank you for asking. A few days ago, I was looking into Navmeshes. This comes in clutch. It looks super cool. Yeah, so this is by no means a complete implementation of Navmeshes. We're just kind of skimming the surface at the moment. Let's see. I would recommend using SDL2. Worked really well for me. Let you focus on game engine concepts without getting too graphics nitty-gritty. Yes, SDL is a really solid choice. The only thing that I would say, I would asterisk that with something. So SDL, I usually would recommend for like windowing, input, sound, those kind of things. It's great for that. However, when it comes to writing your game renderer, maybe for the first one, it's cool to like use their renderer, right? Because they've got some decent tooling in there for that. But at some point, I would break away from using that because it's at that point you're not learning to build a game engine, you're learning to build an application with SDL, right? So you want to be careful about relying too much on a framework like that if you're wanting to learn how to build one of these from scratch, right? SDL is OpenGL. SDL2 is OpenGL now. It can interface with OpenGL, but you still have to like load OpenGL and make the calls to GL. I think it might use GL under the hood. I think. But like that's their own abstraction over that, right? So OpenGL itself is an abstraction from the graphics card, right, from the driver. And then you have SDL, which is some abstraction over that. And then if you write your engine code on top of SDL, that's another abstraction over that, right? So getting the layers of abstraction down to a dull roar is where you want to be eventually. GL on Linux, Direct3D on Win32. Does it not fall back to... Yeah, I guess Direct3D 11 would make sense. I don't know. I haven't used SDL for a project in a long time, so... The SDL renderer backend, I don't know what it uses these days. Use SDL to do windowing and creating the OpenGL context, then I operate with GL directly. Yeah, that's the way I would do it. Yeah. If you're using that. We didn't do that here. I rolled all that stuff from scratch. Because I hate myself, I guess. I don't know. Let's see. I agree. You started to move into OpenGL now. That was the response to someone asking how to get started. Oh, I see. Okay, gotcha. All right. So I think I've touched on the basic concepts of what a nav mesh is, what it's used for, etc. So now what I want to talk about is some of the things that we need to do to actually get it working. I'm just going to kill that and bat that out of the way. So one of the things that we're going to need to know in a nav mesh is essentially the first bit of functionality that we need out of it is the ability to slide the player over the geometry, right? And be able to say, when we get to an edge of the geometry, we want to stop, right? I probably should have left this running for a visual example. I have a bad habit of doing that. Right? So if we take a look at, I'm just going to jump into the editor for a second. And if I switch this to wireframe mode, turn off the skybox and fog, turn off the debug and grid stuff. Unfortunately, the terrain is still there, but you can kind of see, you know what, let me move this up so that we can actually, what do I have selected? Oh, that must have been the spawn point. There we go. Move this guy up a little bit so we can actually see what we're talking about here. All right, so you can see here that we've got all of this triangle data here, right, in the wireframe. And so we essentially want to say we want the player to be able to move on top of these triangles, but whenever we hit one of these edges or we hit a hole in that particular mesh, we want to stop the player. We don't want them to be able to go over the side. Now, that's just a design decision that I'm making. Some games or engines might require that you be able to fall over the edge, and maybe you die when you do that, right? I'm not going to allow that for this game. I don't think it's necessary. I think there's plenty of other things we could do without you know, having to worry about falling off cliffs. I don't see it as a necessity at the moment. So we're going to basically bind the player's movement to this mesh, right? And so if I switch back out of the editor, whoops, let me actually turn on, let's see, regular rendering mode. There we go. And so we can see here that if I go to the edge, I can't walk off the edge of that mesh, right? If I turn around and I go over here, I can't walk through the hole, right? And so the way that we do that is we say, okay, for each of these individual triangles, first of all, which one are we sort of currently standing on? Are we in the middle of that triangle, or are we approaching an edge? And if we are approaching an edge, is there a neighboring triangle at that edge, right? So if we think about the topology data here, I guess I could just open this up in Blender. So if we're standing on this triangle here, right, this particular edge here has a neighboring triangle, right? It shares this edge with this triangle over here, right? Versus this particular edge here has no neighbor, right? This edge has a neighbor. So you should essentially be able to walk from this triangle to this one or to this one, but you shouldn't be able to move this way, essentially, right? And so what we have to do is, beyond just the typical loading of our mesh geometry, we actually have to load up something called adjacency data, or we need to generate that, right? And so essentially what that is it's a data that tells us, okay, for the particular triangle that we're on, if we are colliding with an edge of that triangle, or we're trying to step past the edge of that triangle, what is the index of the triangle that we're trying to step onto? And so that data is a key part of what makes the difference between a nav mesh and a typical mesh where we don't really track that information, right? So the nav mesh itself, we just have this knav mesh structure here, and all this contains right now, it'll contain a little bit more, is an array of triangles and obviously a count, right? And so this knav mesh triangle has the three vertices, right? So the 3 points in space. It has the triangle's normal. So just to bring back Blender for a second, that is these light blue lines coming out of the center, right? So we essentially grab the face normal of that particular triangle, and that's all brought in through the import process. And then we have I32 neighbors, and we have an array of that, right? So if you think about a triangle can have essentially up to 3 neighbors, 1 per edge, right? And so if we take a look at this particular triangle here, this edge has this triangle as a neighbor, this edge has this triangle as a neighbor, and this edge has this triangle as a neighbor, right? And so we don't really worry, at least not yet, about this triangle or this triangle or this triangle, because that's a bit of a corner case, and we're going to have to actually figure that out at some point. But for now, we're just sort of brute forcing this just to kind of get it to work, right? So there are going to be some edge cases where maybe you're traveling from this triangle and you're trying to walk directly over the point over to here. And so there are some issues around that we're going to have to figure out. But for now, we're just going to keep it simple and then make it more robust on top of that. So that is the concept of the neighbor, right? So the neighbor is an index into this triangles array. And so when we think about the triangles, Each triangle is represented by 3 points. Those 3 points are indicated by a list of indices. So we already have all of this information in the meshes that we import, right? So our meshes always come with vertex info and index info to tell us how to actually draw those triangles. And so we can actually use that same exact data to determine the nav mesh and its adjacency data. And so because of the way that our triangulated mesh data is rendered, we are actually required to have a list of triangles, which is exactly 3 points at a time. So the nice part about that is when we go to convert a standard mesh to a nav mesh, we know that we can just iterate through that list of indices 3 at a time, and each one of those sets of 3 is a triangle, right? And so this neighbor is a index into that list of triangles. Now, why is it an I32 instead of a U32? Well, the answer to that is pretty simple. If the triangle has no neighbor, we set its neighbor for that particular edge to -1, right? So I think, let's see. In this example, and I actually have some debug numbers here showing in Blender, right? And so if we look at this is triangle 16, right? And so for edge, so for edge 3, right? We actually have our neighbor is index 22, right? And so we know that if we look at edge 3, which is this 3 is global to all edges within the entire thing, right? So none of these numbers are repeated, right? You can see they're all different. And so if we think about this for a second, we can say, okay, well, the neighbor along this edge for triangle 16 is 12, or is 22 rather. The neighbor for this edge is 33. The neighbor for this edge is 32, right? And so that's essentially how we say, okay, we're trying to move over this edge. Give me its neighbor. Okay. All right. So, with that, that explains how the neighbors work, and then the next couple things are actually the generation of that mesh data, right? And that's what these two structures are for. So a Navmesh edge key is essentially saying we take the vertex index numbers, right, for 2 particular points, right? So that would be, if we're looking at this view, that would essentially be this particular edge here is made up of index 22 and 2, right? And so if we're creating a edge key for that, that's what would go in there, right? And then the edge entry takes one of those keys. It tells us the index of the triangle it belongs to and the edge index in a list of edges that we actually have created for that particular triangle, right? And so that list of edges for that triangle is always going to be 3 long, right? Because every triangle has 3 edges. So it's basically going to tell us what index of those 3 is it going to be. And technically this could be a U8, right? That doesn't really need to be a U32. Because it's only going to ever be 0, 1, or 2. Okay, so we've got a couple of functions here to make a edge key based off of 2 indices, right? And so we're basically going to pass 2 indices to this, and we're going to do a quick check to say, hey, is A less than B? Then we're going to use index A to go into V0 and index B to go into V1. Otherwise, we're just going to flip them. And the reason that we do that is so that the lowest index is always first. And that way, when we're matching edges, we don't have to go through the loop checking forwards and backwards, right? So when we check to see if two edges are equal, we would essentially have to do this check, which is here, instead of just this simple guy. So essentially what we do is we check A V0 and V1 against B V0 and V1, right? And so we can just do this and not have to check it to say A0 equals B0 and A1 equals B1, or A0 against B1 and A1 against B0, right? So this is just here as an example of what we'd have to do if we didn't do this logic here. And so this knav mesh from indexed vertices essentially is what gets us from our model vertex data, right, our mesh vertex data, to a nav mesh, right? So it returns a nav mesh. And all it takes is a list of vertices, right? So those are just positional vertices only, so we have to extract that. And then a number of indices and the array of indices itself, right? And so we probably ought to have some sort of assert in here that, I guess, let's see. How should we do this? I guess we could say, should we just say, well, you know what? I'm not going to worry about that. Let's keep it simple for now. We should probably check to make sure it's divisible by 3. But we're just kind of doing that for now anyways. So the triangle count of the nav mesh is going to be index count divided by 3. So remember, our index list is a list of triangles made of 3 points each. So we iterate those 3 at a time. That's how we get our triangle count. So we set that up. We create an array that is also that size. And then we also create a list of edges. And so we are essentially doing, we have 3 edges per triangle. And we're just going to use the index count since it happens to line up with the total edge count anyways. So since we have our triangle count, which is index count divided by 3, but we have 3 edges per triangle, that's basically going to be the index count, right? So the number of edges that we have for the whole thing is that number. And the reason that we do that, right, is because this technically in Blender is displayed as 1 edge, but technically it's 2, because we have 1 edge definition for this triangle and a separate edge definition for this triangle, because they're going to technically be backwards, right? And so because of that, we just generate them all at once, and we don't check for duplicates or anything because it's simple enough to just do without that, right? So the edges array here is only temporary. We don't actually keep this. This is just for generating the adjacency data. Let me see. Before I move on to actually iterating the triangles, let me catch up on chats. Let's see. In my case, I'm doing... Wait. In my case, the first I'm going the software rendering route and say it's going to be very well compared to what I thought initially. It's amazing how fast modern CPUs are. Yes, agreed. Software renderer is not something... I mean, I've written simple ones, but a software renderer is something I want to do for a future project for sure. Just to see how much I can eke out performance-wise. Because I always thought it would be like one of my future ideas for a game is to actually make a game that's as small as I can possibly make it in terms of file size. And have the ability to basically run it on a toaster. And so having the ability to, or having a software renderer would basically mean it could run on anything. Let's see. What are you using for your GUI? So if you're talking about in the engine itself, we wrote that. We have our own UI system. So all of if you're talking about all of this stuff, like in the editor and whatnot, yeah, this is all a custom UI system we wrote from scratch. Let's see. Started by writing my own window system, but about halfway through, I realized A, I didn't care enough about creating a window, and B, was just creating a worse SDL, so I switched to SDL3. Fair enough about them. The reason I did it from scratch was educational, right? But I wound up actually implementing enough where I'm just like, you know what? I don't actually need SDL at this point. So I've got enough at this point where I don't need it. Shouldn't neighbors be uint 32? No, and I'll tell you why. So if the neighbor, you're asking about this right here. The reason this is I32 is because if we are on a triangle that does not have a neighbor, or I'm sorry, on a edge that does not have a neighbor, like this particular edge, right? This just basically forwards on to empty space. Then that is represented by a -1. And that's the reason for the I32. Now, I could have gone with a U32 anyways and used max end, right? I could have gone that way, but I think in terms of debugging, this was just easier to do. And I don't plan on having any meshes that are going to be, large enough to blow this out. So we should be fine with it. 3D Code Warrior, hello, how's it going? Good to see you. How have you been? Okay. So we've got a few things in here. This actually isn't really as complicated as you might think. There is some stuff in here that I've kind of disabled just because I'm not 100% sure if I'm going to need it or not, but we'll just kind of walk through this, right? So for each triangle, we essentially go through and we generate all of the data that it needs at that time, minus the adjacency data, because that has to be done in a separate pass. So we go ahead and grab a convenience pointer to the triangle, and then we generate, or we retrieve rather, from the indices array the appropriate index for that particular triangle. So index 0, 1, and 2 for that particular triangle. So that's the triangle index times 3 plus 0, 1, and 2. That gives us the correct offset into the array. And then we grab the points. So that's just verts at I0, I1, and I2. And then the first thing that we do is we grab the normal, right? So the normal is basically taken or retrieved rather by grabbing two edges and then taking the cross product of those two edges, right? So the first edge is going to be between 0.1 and 0, and then between 2 and 0, right? So we take those two edges of the triangle, and it doesn't really matter which two we take. We could take any two. But we get those edge directions just by doing a vector subtraction. And then we go ahead and take the cross product of those. So that'll essentially give us the direction that's orthogonal to these two, right? And then we go ahead and we normalize that, and we have our triangles normal. This is something I probably could just pull this out of vertex information, right? But the reason I don't want to do that is because sometimes vertex normals can be a little bit wonky versus the actual face normal, which is what we really, really want in this case. So we want to deal with face normals, not vertex normals. And vertex normals can be a little bit, they might not necessarily give us exactly what we're looking for. And then I've got a commented out block here. And I've only commented out because I don't think we're actually going to have to do this, but I have it in here in place. And actually this hack is not actually even... There we go. It was not even accurate. Okay, so essentially what we do is we just want to make sure that the winding is correct, right? The vertex winding. And so what we're always looking for with a nav mesh is that we want to make sure that the normal is essentially facing up. So obviously this would be a problem if we ever had a nav mesh that went completely straight, like vertical. But I don't plan on having that in this game, so I'm not really worried about it. So we grab the normal of that and we say, hey, is the normal of that, the y of that normal, less than 0? Essentially, is it pointing down? And if it is, we essentially need to swap 2 of the points, and that will reverse the winding. And then we take the normal again and go from there. So we swap 2 of the points here. Let me actually just uncomment this so you guys can actually see it. So we swap 2 of the points here. And then we also swap 2 of the indices in the indices array here. And then we go ahead and reobtain those indices and then reobtain the normal, right? So for right now, we don't need to do that. So I actually have that turned off because we don't need it. The next thing that we do is we create 3 edges based again on that triangle index. So we have that here, 0, 1, and 2. And we create our knav mesh entry. So we make an edge. We've already gone over that function as to what that does. So the first edge is index 0 and index 1. Then the next one is 1 and 2. And then the final one is 2 and 0, right? So it just goes around in a circle. And then ti is the triangle index. And then the edge index is last. So 0, 1, and 2, right? So that's what that does. And then we set, I suppose, some of this stuff I could add into a loop. I like to do things unrolled while I'm kind of figuring it out and then roll it into a loop later. So here we actually set the neighbors all to -1. So we default to saying none of these triangles have any neighboring data whatsoever. And then we use this matching to essentially go through here. And this is what I wanted to turn off. We don't need that on anymore. That's just tracing some data about the individual edge. So essentially what we do here is we loop through all edges, and then we loop through all edges essentially +1 or forward in the array. And we actually don't need this anymore. That's gone. And essentially what we do is we say, are those edges equal, right? And we've already kind of looked at what this does. And if they are, then here's where we go ahead and we set the neighbors, right? So we go ahead and we say, well, in here, what edge are we on, right? So we look at edges I and J, and we grab the triangle index from that, and we use that to go into the triangles array in the out mesh and grab a convenience pointer to that. And then what we do is we essentially set the neighbors of those 2 triangles to each other over across that edge, right? So that's what that does. We've just got a couple of things in here just to count how many matches we have just for output, debug output. And then we've got something in here to check for orphan triangles if there is more than 1 triangle to the mesh. Now, ideally, and I've got some troubleshooting to do around this, but ideally, you should have a mesh that looks like this that has no orphans. And what I mean by orphans is, we shouldn't have a triangle that's disconnected from the rest of the nav mesh. In other words, a triangle that has no neighbors, right? So, we can move this triangle around. We can see that it's sticky, right? It's connected to all these other guys, right? And so we shouldn't have any of these where it says basically all 3 edges are -1. For some reason, I am getting an edge that it has, or a triangle that has all edges set to -1. And I haven't completely figured out why that is. But I suspect it may be an issue with the mesh, not the code, because I haven't found anything in the code yet that seems to be wrong with that. But it's minor stuff like that we're going to have to figure out as time goes on. So essentially, this is just a check, right? We could probably just wrap this in, if k debug, and then, and F. Not K-debug, Kohi debug. Right? Isn't it? There it is. Okay. So this obviously will not happen in release builds, and we don't need it to. All right. And then, of course, we clean up the edges array because we don't need it once we've generated the adjacency data. So that is basically how we generate a nav mesh from indexed vertices. Let's see. Catch up on chat here. I saw a video where a guy made a super tiny single compiled binary 3D FPS. All the meshes and textures were built at runtime using instructions commands. Yes. Is this the thing from like 2006? Let me see if I can remember what it was called. What the heck was it called? Dot Project, I think it was. I can't remember. It was by a German team, right? If I'm thinking of the right one. But yeah, that was really cool. I think it'd be really neat to build a game in that way. Also on the software renderer thing, I had to do it for an assignment in my graphics class, and it really struggled with the rasterization. I think because barycentric coordinates bamboozle me. Yeah, that's fair enough. That takes a lot to get past, frankly. K. Krieger, that's what it was. Yeah. Yeah. This. Yeah, it was all procedurally generated. And it was like 96K or something like that. I forget. 96 kilobytes, yep. Yeah. Entire freaking game in 96 kilobytes. Like you can't even build an executable that size these days anymore. By default. So yeah, I don't know that we'll be able to get it that small these days, but what's happening, Captain? What's good, homie? I like your style, Minister of Defense. I like it. First time chatter. How are you doing? I am doing well. Thank you for asking. Is that a South African flag behind you? It is indeed. Yes. Over there. I'm surprised you can actually see it all the way over there. But yes, there is one over there. Yep. I stayed there for a little bit on a business trip several years ago, and really loved it. Loved my time there. Beautiful country. Okay. Tasty? Yeah. Lekker, yes. Went there for a lekker braai. Yes, 100%. Bunny chow for the win, for sure. Okay. So let's see. Where was I? I know, like, bunny chow is like a super, like, common thing over there, but it was one of my favorite things I had when I was there. It was awesome. Okay. So I've just got a couple of small math functions that we probably need to work into the math library. This is really where the sort of meat and potatoes are in terms of actually navigating along in this thing. So we have something called a sphere controller, which is what I'm calling it for now because I don't really have a better name, because naming things is hard. But what a sphere controller is it essentially is a representation of our player as far as our sort of collision system, if you can call it that, is concerned. So it stores a couple things. It stores a position, a radius, And so that's the sphere portion of it, and then a try. The other thing it should probably have, it should probably have a pointer to a nav mesh, which we do not have yet. Right, so currently assigned nav mesh. Sure. Okay. Because we're only, we've been kind of hacking this together. We don't really have the ability to switch from one to another, but that is something that we are going to need. So essentially, as you might have guessed, we essentially use the position of this sphere controller to then position the player avatar, right? So this is what actually is used at the underlying navigation along the mesh. And then we just sort of move the avatar to match up with what this sphere controller is doing. So that's that. Not really anything too complicated there. This is the main function for it, right? So essentially we have just movement with sliding and radius, right? So we take in a nav mesh, which probably, when we go to split this out into a separate API, we probably are going to wind up getting that off of the sphere controller, not here. Although I don't know, maybe this shouldn't have the mesh. I haven't really fully decided, which is why I kind of did it this way. So essentially, the way that this works is we have a pointer to the mesh, obviously, the sphere controller, pointer to the sphere controller. Then we have the input vector. So the input vector is essentially what direction do we want to go, in the 3D world. What speed do we want to travel at, and then what's the delta time that we're using for the current step. And so obviously if the assigned triangle is less than 0, then we're outside geometry. And we need to essentially snap to the geometry. So this knav mesh snap is not really too complicated. All it basically does is searches all of the triangles in a brute force sort of manner, and gets the closest point on the triangle to the given point that we provide, right? And essentially it basically finds the closest triangle, the closest point on that triangle to where we currently are, and snaps us to that. And so it basically will tell us, here's the new position in 3D space, and then here is the triangle that we are snapping to, right? And then that is used to assign the controller's position and the controller's triangle, right? So we essentially snap to that. If that fails for some reason, we bleat about it, and then we move on. Otherwise, we snap to the nav mesh geometry right? And then we boot. So if we've done this, we don't process anything until the next frame, right? And yes, I put ka there because
I said forget about it, cuz.
I had to. Anyway, making a strategy game in Unreal and considering making everything fixed point world space for determinism. Worried about having to write all the stuff for nav meshes and collision from scratch, but seeing you do this makes it seem more achievable. Yeah, I mean, I haven't got the math fully figured out here yet either, right? So I'm going to start moving this to the engine, but, I've got plenty of stuff that's commented out where I'm trying different things. So I don't have all of this figured out just yet, but I'm going to walk through what I do have figured out, and we'll kind of, you can see that it's kind of working, right? And from there, we'll just kind of batten down the hatches and make it better. So the first thing that we do is we say, if we have no input, right? So we just do a vector3 compare against the 0 vector on the input. If we have no input, boot out. We don't need to do anything. If we're not trying to move, we don't need to be, running all of this logic, right? We could just stay in the position we're at, and it's fine. If we ever have moving platforms or things like that, which I don't think we're going to have, that may have to change, but we'll see. The next thing I do is I flatten the input. So I take all of the y out of the equation if it's there. And then I go ahead and I normalize that, and I say, well, if the length of the input is now less than the epsilon, which is a very small number, right, for Navmeshes, if the amount of input is really, really small, we boot, right? And then the next thing we do here is we essentially split this up into a few different passes, right? So I've got this actually hard-coded to 4 passes. We may need to bounce this up or down depending on how we do. But essentially what we do is each one of these iterations that we do, we apply a little bit of movement to see, if that is going to be valid. And splitting it up that way just allows us to be a little bit more accurate with our movement and predicting whether or not we're going to hit an edge or cross over an edge or something like that. And so essentially what we do is we keep a remaining vector, right? So this starts off as the full amount of movement that we need, and then we knock off a little bit of movement on each iteration, depending on where we land in the logic, right? And so again, we do a length check on the remaining movement, and if it's less than the epsilon, right, which is a really, really small number, then we boot, right? We break out of this and we don't process any further movement. From here, we basically get a convenience pointer to the triangle that we're assigned to. And then we project the remaining movement onto the surface of the triangle. So we get that plane by passing the normal and this vector 3 project on plane here. Whoops, do I not have? So this, again, basically just takes the dot product between the position and normal that are provided, and then scales it by the normal, and then subtracts the position for that, right? So that is basically just us taking the movement and projecting it onto the surface of the triangle. From there, we go ahead and again do a length check to say, hey, after we've projected this thing, do we have anywhere to go? That's, worth anything, yes or no. And if so, or if not, rather, then we break. So the next thing we do is we say, okay, well, what's the new position that we're going to want? Let's go ahead and take the current position of the controller, add the movement to that, and that's going to be our new position. And then we're going to take that and we're going to project it onto the triangle plane. And that will give us our new position there. So the way that this works is we take the dots between the normal and the first point of the triangle. And then we take that and we subtract from it the dot of the normal against the point that we provide here. And then we multiply the normal times the value that we got from this subtraction. And then we add it here, right? So again, we're just projecting onto the triangle plane there, this movement, right? And then we do a radius check with all of the edges, right? So we do assigned distance to edge check for all 3 edges. So edge 0 and 1, right? So that's points 0 and 1. 1 and 2, and then 2 and 0. And so we do a signed distance to edge check there. And then we grab the minimum of all of those, right? So we grab the smallest one. We say, okay, that's going to be the closest one that we're going to want. And then we have in here, is that smallest one within the radius of our controller? Or is it greater? I'm sorry, greater than, not less than. is it greater than the radius, right? So is it is the radius of our controller inside the triangle? In other words, if it is, then we're actually done, right? We could just set the position to new position and break, right? Otherwise, that means that our radius overlaps with an edge, at least one edge, right? And so essentially what we do is we figure out what edge was hit just by looking at the distances that we have there. So we figure out what edge index we want, right? So we 0, 1, or 2. And then we go ahead and we say, does it have a neighbor, right? And we use that edge index. So we say triangle neighbors edge index, right? So if it's 2, it would be, the third side's neighbor. And remember, this can be, this can either have a neighbor or not on that particular edge. So in this case, if we do have a neighbor, that means that our neighbor is going to be greater than or equal to 0, right? In fact, yeah, okay. So if we do have a neighbor, then we go ahead and we grab the neighbor triangle, and we do kind of the same stuff we did above, right? So we project the new position onto the neighbor triangle. And then we do another radius check within that, right? We grab the closest edge. We say, does our radius fit within that particular triangle and not bump into any edges? And this is, I've got some problems around here, so I've got to figure out some of this, right? Because obviously these two blocks are the exact same. But for right now, if we're within the next triangle, then we're going to go ahead and proceed, right? And basically what that means is we're going to say, okay, we'll set the position, we'll set the try, and we'll consume the movement, right? So we're basically going to subtract the movement that we've done from remaining, and we're going to continue onto another loop, right? Because we may be crossing more than one particular triangle. And if we are not, if we hit again, then basically we're going to need to kind of do this same thing again, but I haven't worked out exactly how I want to do that yet. And so for right now, I'm kind of just having it do the same thing, but this is definitely not correct. So this I do have to figure out. Going to have to play around with that and figure that out. If we hit an edge without any sort of neighbor, then all we're doing right now is just debugging, writing out, right? And right now this will only ever write out if the neighbor is -1. Okay. So in this case, if we did cross into another triangle, either way, we're going to be continuing, right? So our only other scenario, if we get to here, is we basically come to the edge of a triangle where there is no neighbor. So that means that we need to slide along the edge of that triangle that we're hitting, right? And so here we just grab the edge as appropriate, depending on the edge index, right? So we grab the appropriate points, and then we grab the edge direction for the edge that we're actually hitting. And then we project the movement, instead of onto the triangle, we project it onto the edge, right? So basically what we're doing is we're saying, take whatever movement we've got left over, and instead of trying to continue in that direction, project it along the edge to make us slide, right? And so that's what is actually happening here. And then we add the slide position here. We project it onto the triangle plane just to make sure that it's following the triangle. Probably don't need to necessarily do this step. We could probably skip that step. And then, of course, we clamp to the radius. And so basically what this means is that we do another sign distance check just to make sure that we are within that particular triangle. And so if our radius is actually trying to step over the edge of that triangle, this basically shoves it back from the edge so that the radius doesn't step over the edge of the triangle. And then we use that as kind of how, which actually, come to think of it, that might be an issue too. Because if we are not, well, I guess I don't know if we actually need this check. Really, we should just be able to apply this and move on. I guess if we are, wait a minute, let me think about this. So, yeah, so if we are trying to step out of the triangle, then we should essentially stop that completely. I'm not sure that this is correct, though. I think we should always be trying to slide. Unless doing that slide is going to make the point and the radius move outside of the triangle. Yeah, I think that's correct, actually. So like I said, I've got some things in here to figure out, right? But I've got the bones of it in place anyway. Let's see. Magetsub. Magetsub's in chat but can't chat. Hi, Magetsub. How are you doing? Good to have you here, although you can't chat for some reason. Twitch layout is borked, so I cannot participate in the chat. Your Twitch layout, like on your machine, is borked? Weird. Adam Rushford over on the YouTube side. How's it going? Good to see you. Let's see. Hope you had all the good stuff. Malva pudding, bri. I can't remember how to pronounce that. Bruiges. Is that the pastry? Is that like the little pastry thing? Or am I thinking of something else? It's been 7 years since I was there, so my memory's a little foggy on what some of the things were called. But yeah, I had lots of tasty stuff there. Toasted sandwiches, but for BBQ. Okay, yeah, now I know what you're talking about. Okay. Yes, I did have that. It was awesome. Let's see. One question, creating a math library for vectors and 4D matrix, pure C, no CPP, bool included. I'm making it type agnostic. So from short to long, double, using macros to generate and dispatch. Okay. That makes sense. Is this a dumb idea? It sounds like what you're trying to do is templates in C, essentially. Which, I mean, I get. Because a lot of the, there's going to be overload and a lot of, not overload. There's going to be overlap in a lot of those functions. Here's the thing, though. Like, with my math library, I've only added the stuff that I've ever needed. So I just have different versions of the function, like for each type. You wind up getting the same thing out of macros anyways when it compiles. So I don't know. To each their own. I don't think it's a dumb idea. I don't know if I would write all of it though for... Well, I guess you're not going to write all of it if you're using macros though. I don't know. Like I've not really used shorts in a math library, for example, right? So yeah, I don't know. I would say keep it as simple and performant as possible. Make it performant. Worry about flexibility afterwards, right? Well, wait, no. Make it right. Make it performant. Then worry about then worry about, making it flexible. If that makes sense. Let's see. RMK, how's it going? Hi there. Just wondering what kind of memory allocators you're using in this project, mostly arenas. Yeah. So we have a couple of main types. The primary one and I have like different names for them, but essentially the dynamic allocator is essentially a huge arena, right? It's essentially my replacement for malloc. We've got a huge arena and it's got a free list that it maintains internally, and it just doles out memory out of that. It does a huge allocation and just doles out memory out of that huge allocation. And then I've got something called a linear allocator, which is also known as a bump allocator. And I use that one for performance critical sections. So anything that has to be created mid-frame, that's done every frame, like when we're building out rendering lists or something like that, I use that, and then that gets reset every frame. So all that one does is just moves a pointer along a single block of memory. It doesn't free anything, it doesn't track anything, it just does that. And so as a result, it's lightning fast. But obviously, you'd only use that in situations where you absolutely need the performance. And then, of course, I've got a pool allocator. Should be fairly self-explanatory. I'm actually underusing that one a little bit. I need to use it a little bit more. But those are the ones I've found need for, at least for now. In the entire memory system, by the way, so whenever I call kallocate anywhere in the system, it's using the dynamic allocator by default. Okay. Hope that answers your question. Let's see. Where were we? So we got past all this. I think I got past that. Yeah. We talked about the snapping. All right. So here's the hacky section, as denoted by all the hacks, right? So the way that I put this together, like I said, is as I was sort of prototyping this and troubleshooting and working it out, it made sense to just kind of put this stuff in the game code until I had it finalized. And to be honest, I may not actually move it from here just yet because it still does need some work and some troubleshooting. But essentially, we've packed everything into the avatar player on update function. And so essentially what we're doing is we're creating a new sphere controller every single time, which is just, we're creating it once and then updating it every single time, right? So we create it statically here. Again, this is a hack. Obviously, this should not be here, right? But we create it with some default values, right? I'm working with a really small radius right now. Eventually, that's probably going to be like a 0.5 radius or something like that. And a default position, and then triangle defaulted to -1 for that ID. And then essentially what we have to do, and I'm doing this every frame, and I'm doing this just for simplicity purposes, but eventually this is going to be built into the scene, and this code will run once, essentially, or at least the first part of this code will run once. So what we have to do is we reach into the scene and we grab an entity that is named test navmesh. And right now I do this every frame. Obviously not ideal, but again, it's a test hack. I don't really care. We're going to be moving all of this and throwing out this code anyway. So this stuff doesn't really matter. I'm just kind of explaining how I am approaching sort of working through this problem for now. So I didn't want to have to like cache this somewhere and then, reference it somewhere. It's just easier to just do it every frame, right? So obviously we make sure that we got the entity, we grab the entity's transform, we grab the world matrix from that, and then I grab the model instance from that particular entity, right? So I know it's a model entity. We go ahead and we grab the model instance, which allows us to say, hey, is the model loaded? If the model is loaded, let's grab the geometry from it, right? From there, I can grab the vertices and the indices. I can take in just the positional data from all the vertices and then create a nav mesh from that, right? So again, I know this is bad. I know we're doing it every frame. I don't care at the moment. This is all something that would happen. It would probably be tied to the load of the scene and or a nav mesh entity type, right? And when we load, this code would run once instead of over and over. So we go ahead and we grab the K nav mesh from that. And then we go ahead and we free the temporary verts array that we created up here that had only positional data. And then we go ahead and we grab the base transforms position of the player avatar. We check whether or not a snap needs to happen. So when we first load in, trigger snap is going to be true. And so the first time that this runs through, we'll go ahead and snap the mesh to the given mesh here, nav mesh. And then we'll flip that flag back to false. Again, that's another hack. It's a temporary thing just so that we could get something working. The next thing we do is we say sphere controller move along nav mesh, and here is where we put in the input move, the speed multiplier, the base forward movement speed, the delta time, all that good stuff. And then here is where we set the position that is set on the controller from this particular call, right? And so that is sort of the way that all of this stuff is tied in. Again, hack upon hack upon hack. But this kind of thing allows me to very quickly set up the code, get something up and running, get it working, and then we can make it right and move it into the proper location afterwards. So this is, a good use of static variables, for example, right, is something exactly like this. You wouldn't want to leave this in production code, obviously. That's terrible. If I were to hot reload this, it would break. This should obviously be stored elsewhere, right? But there we are. Okay. Seeing you code gives pretty cool insight. Thanks. Oh, glad you find it useful. That's awesome. Okay. Is there anything else that I'm missing? I don't think so. I think we've covered everything else about avatars. So that is basically the way that works, right? So there's obviously a lot of things with this that need improvement, and there's some badness in here we have to take care of. But at least we have something that kind of sort of works, right? So there's a couple of issues that we've brought up in terms of skipping more than one triangle. If I were to actually run this at the moment, there's a couple things that have happened. So if I hit a vertex just so, I can actually get stuck on it. I've got to find one and hit it exactly. I don't know that now, of course, it's not going to do it when I'm trying to, show that thing happening. The other thing that happens, though, is you can actually see where the geometry here meets, where these different triangles meet. And so if I slide along an edge right here, it doesn't smoothly transition me from one edge to the next, right? I have to sort of back off and then come this way, right? And so that's bad, right? We don't want that. We need to make it smoothly transition from one to the next. And then I've got a couple of things here where some triangles don't have any adjacency data, like this guy. There's one triangle here, and if I go around to the other side, there's one triangle here that doesn't for some reason. And then here, right, that triangle right there has no adjacency data, and that's the error that you're seeing pop up there. This is basically saying that triangle is orphaned when it really shouldn't be. So the next thing I'm going to have to check is basically this is the OBJ that we have that we import from. So this is that actual model itself, exported from Blender. So this guy, and all of this in here seemed to be valid to me. I didn't see anything that was out of whack here. So I think one of the next things we're going to have to do, and I was going to put this off, but I think it's probably the next thing that we're going to cover for the next video, is I think we actually need to have some sort of model viewer in the application next, right? So where we have the ability to open up the application and go into the editor, I think we actually need to have like a separate view of this, where instead of rendering the scene, we render a model where we can rotate it around, view various aspects of it, be able to look at maybe things like adjacency data, things of that kind of thing, right? But I think having one of those would be super useful, instead of having to try and load up, in a view in the rest of the world like this and try to do it through this particular view, right? And also, it might be nice to have a model viewer that we can view animations in and view a list of animations and be able to select an animation and have it play and some things like that. So I was going to move away from the editor stuff, but I think for this, having some sort of viewer like that might actually be super helpful. So just write tools and build on what you make. Exactly. That's what we're doing. Yeah. Let's see. Do you have a short video explaining what you're working on? Seems like an RPG, but I'm sure there are cool design mechanics you're planning. Yeah, so short video? No. It's not far enough along. I do have... Give me a second to pull it up. So I do have, and sorry for the flashbang, I do have this Google Doc that has a bunch of stuff in it. So it's got lore and a whole bunch of information about all the various zones in the game and some background story with them. And then I've got wanted mechanics in here, and a breakdown of those different things. Some of the various things that we want features in the game, things like quests, difficulty levels, combat mechanics, right? How combat's going to work, what death is, whether you can have, be over-leveled or not, boss mechanics, progression, melee combat, equipable items, there are different types, things like that, armor, spells, range combat, summon spells, debuffs, curses, buffs, blessings, those kind of things, right? Animation ideas, things that we need in terms of mechanics for UI, control schemes, engine features needed, which this probably needs to be updated, and then a whole bunch of zone and name ideas, mechanic ideas for different stuff, quest ideas, dialogue system, all kinds of stuff, right? A dingosaur, right? So do not implement Elder Scrolls style difficulty. So one thing I can't stand with difficulty is, in a lot of games, it's basically just a sliding scale of numbers of the math model, right? It's like what I consider an artificial challenge. So they'll just boost the amount of damage that enemies do and then reduce your damage reduction, essentially. And it just makes everything hit much harder, right? And take a lot longer to kill. I'm not a fan of that. I don't find that to be difficult, right? I think difficulty should affect other aspects of the game. I think I actually had I did have it in here. Where is that? I need to organize this document a little bit better, but it's just basically a stream of consciousness. Here we go. Difficulty level. So like I have some ideas on things that we could change, right? So like an easy mode, accessing menu items will pause the game so the player can't be attacked during that time. But maybe on hard mode, it wouldn't be, right? So if you're in the menus on hard mode and you're, I don't know, crafting something or you're messing with your inventory, you can be attacked during that in hard mode, right? That would be a hard mode thing. Versus easy mode, it would turn that off. Maybe there would be an enemy aim assist with spells and projectiles where they'll automatically aim directly at the enemy that you have targeted if the player is rotated within a certain range, greatly increasing the hit chance. Whereas if you're in hard mode, it wouldn't do that at all. You would be expected to align your player's direction towards the thing that you're casting at, and you need to just basically fire it in that direction. Things like world hints, right? So you might have like yellow paint highlights or that kind of thing enabled in easy mode, but that would be disabled in hard mode. Things like the tutorial at the beginning of the game to tell you how to play. You wouldn't get any of that in hard mode, for example. Things like maybe even not having a map available to you in hard mode. Like that's the kind of stuff I think that makes it challenging. Not just, making something a bullet sponge, essentially. Yeah. So anyways, so this is the sort of document that I'm working out of for now. And then I've done some world mapping as well. I should have clicked load before I was talking about the other stuff. Hell's Dragoon got me with a raid of 21. How's it going, buddy? Welcome, Raiders. So for those of you who don't know who Hell's Dragoon is, it's actually a team of chaps working on an NES game. Yes, the original NES and 6502 assembly. There's some Giga Chad stuff going on over there, so I highly recommend you check those guys out. What'd you guys get up to on stream today? You beat me to the raid because I actually was explaining something instead of raiding out. You got me. Did nothing but talk and complain about game development. That's a solid stream. I like that. So yeah, we were just basically, I was wrapping up for the night here. I was just kind of trying to answer some questions in chat. We were working on Navmeshes, navigation meshes. So that's basically when you're, here, I'll just show it actually. Let's see, do I actually, I still have it open. Okay. So that's basically when you're running around with your player in 3D. You're basically constrained to this particular mesh that we have here that we're just visualizing as a white mesh, right? And it means that you can't like step off the edge, right? You'll just kind of slide along that or slide along any holes in the geometry. And that's basically what that's used for. And then it can be used by the enemy AI too to say, well, if I'm standing here and there's an enemy over here, he can use the triangle data to figure out how to get to me in the shortest path type thing. So that's what we were kind of going over a base implementation for. And then somebody had asked me about the game that I'm creating. And so that is Shadows of Aluminina, and we're kind of going through the design document a little bit. And then I was just going to quickly show off the world map, right? So it's not done either. Still very much working on this, but here's a bunch of basically the zones that I've got worked out so far. And I've actually got a bunch of lore, kind of background lore written up for this already as well. But I don't have near enough time to go over that here now, but I do have previous streams that have that stuff. So, yeah. Let me see. 4 hours of just talking. Everyone said it was our best stream. That's, oh man, that makes me sad I missed it. Follow the raid train. Fair enough. What's your hot take on indie game development with the goal of making money? Don't do that. I would say that's more of a lukewarm take, really. Because pretty much everybody says that, right? That's my take on it. Don't do that. If you're going into indie game development to make money, chances are it's not going to happen. Hate to be the bearer of bad news, but how do you gauge success with your current project? Oh man, heavy hitters. All right. I would say, to me, I would have a number in my head. And I probably would not base that number off. It wouldn't be a financial number. It would probably be a number of sales or something that I would want to meet. And I would consider the project a success if it met that or exceeded it. And the factors to get there was, does it not suck? Do people like it? Is it high quality and something that you'd be proud of showing off anywhere? Like if somebody at work asked you about it, and would you want to pull that up and show them, for example? Is it something that you could show off proudly? And if all those things are true, I would say, yeah, that'd be a success. There's a doozy over there. Yeah, I mean, that's good question, though. This reminds me of Ultima Online, the map, I mean. Does it? I haven't actually looked at... I've never played Ultima Online. I've never seen the map, so I don't know. Let me see. World map, I guess. Well, okay. I mean, I guess kinda ish. I don't know how accurate this is, but I guess that one maybe. Incarnate makes some very Ultima-ish maps. You should check it out. It's fun. Yeah, it is a great. This is a great utility. I actually signed up for the yearly. It's like $25 a year, and you can make high res maps with this, and they give you like a lot of these sort of preformed stamps that you can use all over the place. I have this in low res mode right now because I don't want to completely kill my browser. But you can actually make like I think 8K maps out of this. But yeah, I mean, they've got all kinds of different cool things that you can add. And I thought it was such a cool project that I used the crap out of the free version. I'm like, you know what? I'm going to pay for this. So I went ahead and signed up for it. Totally ripped off the whole land and also water concept. That's, I know, right? I should have gotten rid of the seas and just had nothing but land the entire way. I'm going to remove water from my engine, actually. Game of Thrones type map looks cool. Yeah, I mean, it's a work in progress, I'll say that, right? I've got this whole section over here I haven't defined yet, and this stuff is probably going to be split up a little bit more. Boat mechanics coming soon? Probably never. I probably will not implement boats because I don't have a physics system. Let's see. Like the idea of risk reward difficulty. Harder difficulty means enemies will have access to better spells and equipment too. Like an easy mage casts fireball, hard mage knows firestorm. But yeah, that's a reasonable example, right? They have different moves and stuff they can use for difficulty. I agree with that. But they also drop better loot and give more XP. Yeah, I mean, and that's the thing, right? Like, I think difficulty modes should affect more than just that, though. It should actually be like hard mode would remove some creature comforts type of thing. All right, El Dragoon, have a good one. Good to see you. Thanks again so much for the raid. I really appreciate it. Just make it a single quad. Yeah, just make the whole map just one quad. I like that. It's like a step down from Daggerfall, right? I love it. All right. Anyways, it is time for me to end. So while I do really appreciate the raid and all of the interaction, I do need to find somebody to raid. So let's see if I can find something that is reasonably related to what we're doing. Let's see, same category. Is there anybody doing C or C++ stuff? Doubtful, but maybe. Spare with me in just a second while I scroll through this. Oh, okay. I see who we're gonna raid. And actually, he's only been up for a couple minutes, or not even a couple minutes. Wait, no, that's 43 minutes. Never mind. He's been up for a while. All right, we are gonna raid Moodwood Games. He's making a retro dungeon crawler that uses blackjack as the combat mechanic, which is actually really, really cool. So I want to set that to the YouTube side as well. Because YouTube has that now. I just have to remember how to actually get to it. Always takes me a minute. I think it is... Here we go. There we go. All right. So we're going to forward the YouTube side over to that as well. So anyways, if you guys haven't already, I would greatly appreciate a follow, and either on the YouTube side or the Twitch side, if you haven't already, or both if you're so inclined. I would appreciate that. And we will be back next week with another stream. Thank you guys so much for being here. I appreciate you guys, and I will catch you guys in the next one. See ya.